Hello, this is Professor Stephen Nesheba, and I'm here to help you out with some radiative balance equations simulations using Excel. So I'll just take you through the basic idea here first, and then we'll get into some of the nuts and bolts. But here's the Earth's energy budget. We can see the shortwave coming in, absorbed by a surface being 163.3 watts per meter squared, and so forth. And what you'll do in Excel is set up a sheet kind of like this, where here in the A column we're just entering fields, text that remind us what we're dealing with, and there's going to be numbers in the B column. And I've kind of coded this so that numbers that you enter, they're in black, and then there's what's called entering a formula that will do in red. And if you'll look at this a little bit more carefully, what we have in the next picture is how those fields are filled in. And so, for example, we're going to enter a value of 0 for the temperature in Celsius, and there's going to be a formula. You'll enter a formula that converts temperature in Celsius into Fahrenheit, which is done, by this formula. You take the temperature in Celsius, multiply by 9, divided by 5, and add 32. To get to the temperature in Celsius to the temperature in Kelvin, you just add 273 to whatever value is in, as you can see in that B2 cell. That's what that syntax means. The shortwave in we've just entered as 163.3, okay, because that's that number. And let's see, the long wave out, that's what we're going to calculate using the Stefan-Boltzmann formula, which remember is sigma times T to the fourth. Well, that's the temperature field right there in Kelvin, and sigma is 5.67 times 10 to the minus 8th. So we've entered this formula equals 5.67 times 10 to the minus 8th times B4, that's the temperature in Kelvin raised to the fourth. And then finally, this imbalance here, it's a box which just says, oh, I really want to look at the how much energy is coming in minus how much energy is going out. So that cell says enter the value that's in cell B5, which you can see is the shortwave in, and subtract away the value that's in B6, which is the long wave out. And if you enter in that value 0 there on 163.3 and you have all these formulas correct, then these should be about the numbers that you see.